El Niño. It's a name that brings to mind chaotic weather patterns from torrential rains and flooding to scorching heat waves and devastating droughts. But what if I told you that the secrets to predicting El Niño's future impacts lie buried in the past? El Niño is a natural climate phenomenon, characterized by periodic warming of sea surface temperatures in the central and eastern Pacific Ocean. This leads to significant disruptions in global weather patterns, causing extreme events like droughts, floods, and heat waves. It's a formidable force of nature, affecting ecosystems and human societies across the globe. Kaustubh Thirumalai, an assistant professor in the University of Alberta's Department of Geosciences, highlights the pervasive impacts of El Niño. It disrupts everything from agriculture to the aviation industry. Given its global reach, understanding and predicting El Niño's future behavior is a critical challenge for climate scientists. The tricky part? Current climate models don't agree on how El Niño will respond to ongoing human-caused warming. Some models predict an increase in El Niño variations, while others suggest a decrease. It's a complex phenomenon, and addressing this uncertainty is a key priority for climate science. To tackle this, Thirumalai's research team turned to the past, specifically the last glacial maximum, about 20,000 years ago when ice sheets covered much of North America and Europe. Using the Community Earth System model, a sophisticated tool developed to simulate Earth's climate system, the team simulated conditions from the last glacial maximum to the present day. This model, primarily led by the National Center for Atmospheric Research, aims to predict future climate scenarios. To validate their model, the team compared its results with data from tiny marine organisms called foraminifera. These microscopic creatures float in the upper ocean and build shells that lock in the ocean temperature of their time. After they die, their shells sink to the ocean floor and become part of the sediment, preserving a snapshot of past ocean conditions. By analyzing these shells, scientists can reconstruct ocean temperatures from thousands of years ago. The team focused on individual foraminiferal shells to capture seasonal temperature variations, giving them a detailed picture of Pacific Ocean temperatures during the Ice Age compared to today. Their findings? El Niño variability was significantly lower during the last glacial maximum compared to the present day. This suggests that as our planet warms, we could see more extreme El Niño events, leading to more frequent and intense weather disruptions worldwide. Thirumalai points out that these findings validate the climate model's predictions. If the model can accurately simulate past climate changes, it's more likely to provide reliable forecasts for future El Niño behavior. Understanding these patterns from the past gives us a crucial tool for preparing for future weather chaos. So every time you hear about an El Niño event, remember, our ability to predict and understand it might just come from the ancient clues left by tiny ocean creatures millions of years ago. Thanks for tuning in. If you found this interesting, don't forget to like and subscribe to Science Rise On for more insights into our wonderful planet's fascinating climate system.